will start in just a few minutes. Let everyone join. Okay, wait for a while. Good morning, everyone. Okay, so we will start with this stuff. I think that I'm audible to everyone. Am I audible? Is there any issue with that? Okay. Somebody can please open their mic and confirm me. Is it audible?
Yes, audible.
Yes, sir.
Okay, just a second. Okay, so I think this is audible to all of you. And let me just start with the today's topic. So today topic of the discussion we have, which is related to the transmission media. Okay, so what is the transmission media? What are the importance of that? And that's the main chapter, I can say, which is actually related to that type of cables or type of communication actually going to be happening. So up to the previous chapter, what we have discussed about the technique, communication standard, and such type of a thing, signaling technique, type of signal conversion and all the stuff. But in this lecture, what we need to we need to discuss about that. Is there any issue with any audio? Hello, is it coming properly or some? Is my voice is coming properly? Yes. Okay, chale, yeah. So in the transmission media, if we can discuss with that, what are the things is associated with transmission media? So transmission media can be anything. It is either a guided media or it's unguided media. So guided media, it means there are a specific cable is there. Okay. An unguided media, which is an open space. So, what is the task of the physical layer on this with this cable and air? So, whatever the data coming from the physical layer, whatever the signal is coming from the physical layer, according to those signal, whatever the signal is going to be there inside of your cable, like you can say if you are having a coaxial cable, so there are some electric signal are there. If there are optical signal are there, so there are fiber optic cables are there. So guided media just carry those signal and send those signal from one place to another place. Okay, so transmission medium is a task to transmit that data or transmit that signal which is generated through your antenna or through a transmitter from the physical layer from one place to another place. So these are the main role of the cables, okay, in your actual communication. So depend on that types of the cabling, there are two basic fragmentation are there. First is a guided media, another is going to be unguided media. So what is a guided media and what is unguided media? So guided media is considered as a wire connection and unguided media is a wireless connection. So we can say under the wired connection, what are the stuff we have? It is a twisted pair cable, coaxial cable, and fiber optic cable. So twisted pair cable you have observed in your LAN connection. So whenever you see the LAN connection at the time, there are a twisted pair cable is there. Whenever you are having a television transmission, whenever you have a DTH transmission, at that time there are a coaxial cable is going to be used over there. As well as for the optical communication from for the high speed data transfer, fiber optic communication is there. While in unguided, which is also known as a wireless media, it is a free space. Free space, it means air. So whatever the Wi-Fi, Bluetooth, mobile communication, satellite communication, all this type of the communication came under the free space communication. Okay. So there are two basic differences there: guided and unguided, wired or wireless. So what is a guided media? There are three basically classification is there: twisted pair, coaxial, and fiber optic cable. So we need to see this type of the cabling one by one. So the twisted pair cable will be like this one. So that cable is going to be twisted to one to another. Like if you can say there are eight cables are there in your LAN connection, whatever the internet connection you are taking in your laboratory or whatever the LAN connection given by the GTPL, sorry, GTPL or whatever the internet service provider will give you. Those are the twisted pair cables. So there are eight cables are there which is twisted. Okay, it is twisted on one another, and it is the having a connector at the end. Okay, and from that connector there are different signals are there, and that you need to attach with the adapter, and you can use it for your data transfer. So that's the twisted pair diagram, like how it will look like. Another we have like in a twisted pair also there are two category: UTP and STP. So unshielded twisted pair and shielded twisted pair. So what is unshielded twisted pair? There are no metal shield are there. Okay, so it is just having a plastic cover and then twisted pair cables are there. While we can say in a shielded twisted pair cable, there are extra metal shield are there in between plastic cover and the cable. Okay, so to avoid the interference between a huge bunch of cabling, like there are one twisted pair cable is going on, along with that there are another twisted pair cables are also there. So avoid the interference. Sometimes there are a metal shield are there just after the plastic cover. So this is the one extra thing we have whenever we have this twisted pair cabling. Next we have, just a second. So if we can see what is a twisted pair and where it is going to be used. So what is the use of twisted pair cable? As I have told you, in a telephone lines, or we can say in a twisted pair originally used in a T line, which is actually known as a telephone lines. While we can say in other LAN connection, whatever the internet connection are there, which is under the category 2, category 3 ring network, normal local area network, then check it outside the seat, or we can say to minimize the crosstalk. Like we can say for the smaller to the higher data rate of the requirement, this twisted pair cable is going to be used. That so maximum twisted pair cable having the speed of 600 Mbps. So you can see that, like with respect to that the number of cables and all the stuff, 600 kbps 600 mbps of the speed you can achieve for the up to different category. So for the telephone line in kind of the normal kind of the data transmission, or we can say with the higher data rate, that number of cable twisted pair cable is going to be changed, or we can say it is having their different characteristic, like someone having their extra cable twisted inside of that. There are metal sealed are going to be there. So here it is just only for the unshielded twisted pair. Well, we can say what type of the connector is associated with this one. So as we have seen, there are two cable is getting twisted. So this is the one particular connector diagram is there. So in this connector diagram, what are the stuff we have? Like in this connector diagram, we are having a 8 twisted pair cable are going to be fitted, and it's considered as a RJ45 female and male connector. So this type of the connection is going to be this type of the connection is going to be is available. Okay, like this female connector is available in your laptop or in your PC. Well, we can say that male connector which is available in your, you can say male connector is available in your cable which is going to provide by service provider. So such type of the male and female connector are there. So there are 1 to 8, there are different color coding of those cables are there, and you need to set it according to that color. And when you fit it to this particular cable, it is going to be rightly connected with this female, and internet access you can get it. So such type of the male and female connectors are there. Just a second. Next we have, it is a UTP. We can say what are the unshielded twisted pair performances there. So over here there are a consideration over here that if you are going to increase the frequency of your uh, information, or we can say info frequency of your communication, okay, at that time there are attenuation is going to be, because over here there is the uh, graph related to gauge. Now gauge is related to the diameter, that what is the diameter with respect to 18 gauge, 22 gauge. So it's in terms of inches. So if you can say more and more, we can say that with respect to the different gauges, you are having a I can say smaller and smaller amount of the inches are the diameter is going to be a decrease, you can say. Okay, so the stuff is going to be related, like if you are having a higher gauge of the uh, cable, or we can say there are I can say thinner gauge of the wire, at that time the attenuation is going to be increase, okay, as you are changing your frequency. So here there is a profile, like for the thicker wire, we can say there are a low attenuation as compared to the 26 gauge wire. So we can say as you are increasing the gauge, okay, and wire become the thinner, and you can say there are attenuation profile is also going to be rise. So we can say if we are having a thick cable, the attenuation is a little bit low, but if you have thin cable, attenuation is going to higher for the higher rate of the frequency operation. So that's the UTP performance. Same type of the UTP performance we have with the coaxial cable also and optical fiber cable also. Next type of the cable, which is a coaxial cable. So coaxial cable having a several layer. Such type of the cable you can see at your home when you are having uh, those one connection, okay, with your DTH set top box. So if you just see your back end side of your set top box, there are a such type of the cable is there which is known as a coaxial cable, and this coaxial cable is connected with your top parabolic antenna, satellite antenna. Okay, so whatever the television set top box you have on the back end side, such type of the one cable is there which is connected with your dish TV antenna. So it is having a inner connector, thick metal wire is there. copper wire is there, then it is having a multiple layer of insulator, there are some conductor sealed are there, plastic cover are there. So such type of the coaxial cable is going to be formed. Okay, these are the category, like there are a different impedance are there, and they are having category of RJ59, RJ58, RJ11, and it is used for the different type of the application. Like if RJ59 is there and it's a 75 impedance ohm, so it's used as a cable TV. Now what is this impedance over here? Just listen it carefully. Impedance, it means what is your connector and what is your, I can say, socket, what are the resistance of that. If you have seen or if you remember any circuit electronics related subject, so you know that there are one term is come as a maximum power transmission. So what is a maximum power transmission? That whatever your cable impedance and whatever your, I can say, connector impedance, when both going to be a match, when both going to be equal, then and then maximum power going to transfer from one system to another. It is happen with the similar type of the stuff, like whatever the uh, you can simply say like that. Let's say there are one of the pipe is there. Let's say there are a one pipe having some water capacity, another pipe having the having the water capacity. Now if both pipe is not going to be in a similar in diameter, so we can say maximum water flow, if it is not both are in the same diameter, so maximum power flow or maximum water flow never going to. अगर एक पाइप है वो बड़ा है, एक पाइप छोटा है, अगर वो दोनों को आप कनेक्ट करोगे तो पानी बीच में से निकलेगा ही, लॉस होगा ही. Likewise the same stuff in impedance. If the impedance of the both of the side cable is not going to match, then we can say that maximum power transfer cannot possible. So whatever the cable TV or that cable TV you are cable you are making for such television application to connect with the television and set top box, so we require the 75 ohm of the cable, while for the rest of the application that 50 ohm of the cable is also going to be okay with that. These are the connector are there. So such type of the BNC connector are there, which is used to connect kind of the such type of the T shape of the junction. And in the another side, there are a ground wire, there are a 50-watt BNC terminator are there. So these are the different type of the connector. This is a cable. This is a T of that BNC. This is kind of the ground wired base at N terminal. So such type of the different connectors are there, which is associated with your coaxial cable, and by using such connector you can connect to the different device, whether it's a set-top box or some of the ethernet connection and like that. This is the profile. If you are increasing, or we can say if you are just increasing your diameter, if you are having a higher diameter at 9.5 millimeter, so we can say with respect to that your frequency attenuation is going to lower. But if you make your cable thinner and thinner, if you are whatever that copper cable is there, if it is very thin, so at that time your profile, or we can say your attenuation dB per kilometer is also going to be increase for the higher frequency region. So this is all talk about 100 kilohertz or more, like up to the 1000 kilohertz. So this is the profile. So up to the 100 kilohertz, it is having a limitation. Like अगर आप 100 kilohertz का signal आप भेज रहे हो, और आप उससे higher data rate चाह रहे हो, so with this both of the cable, it is not possible. If you want to need a higher data rate on Mbps, Gbps, you must go with the optical fiber cable. Why? Because that coaxial cable and twisted pair cable having their own capacity in terms of loss, in terms of attenuation. So after the sum of the frequency, signal is going to be lost, losing from that information, getting losing from that. So we need some alternate solution for the higher data rate, and for those alteration we are having a concept of optical communication. Now optical communication is used on a principle of total internal reflection. Now total internal reflection, what is the meaning of that? So for that, there are one experiment is going to be shown over here. Let's say there are two medium, less dense and more dense. Let's say there are a water is there and there are air is there. Okay, and you are launching a light from the water. आप पानी में से कोई एक लेजर बीम आप इंसिडेंट आप लॉन्च कर रहे हो एयर की तरफ. Okay, so whenever you are launching some light from their dense medium to the less dense medium, at that time like whenever there are a boundary between them, जो भी बाउंड्री होगी वो दोनों के बीच में, from that boundary and the tangential component of both of them, that wave, whatever the angle of that kind of the transmission, it's going to change. So if you have launching with that I angle, so whatever the angle is made up over here, let me just take a list. So whatever the angle made up over here, it is differ. It is not same as I. So that angle and this angle both are going to be differ if you are having a such lens and dense medium we have. If you are increasing this, so meaning of that, if you are increasing this angle of I, sometime it is happen that whatever the reflection or whatever the transmittance angle are there, it is sometime reach to the boundary only. Okay. And even if you more increase that incident angle, so that your signal is going to be reflected back completely. This example, or we can say this type of the observation, you can do it whenever you find out any chance to see the fish tank. आप देखिएगा कि आप फिश टैंक के ऊपर आप फिश टैंक को देख रहे हो कैसे, लाइक ऑन जस्ट ऑन योर होरिजोन, आप उसको सामने से ही देख रहे हो. नाउ इफ यू चेंज द हाइट ऑफ योर ऑब्जर्वेशन इन द फिश टैंक, ओके, slowly if you increase the height of your observation in the fish tank, आप पहले फिश टैंक के थ्रू देख रहे थे, अभी थोड़ा अप जाके आप वो पानी के अंदर से देखने का ट्राई करोगे. So after some time, if you change this angle, you will say like that whatever the fish are there, it is coming on the top of your water level. एक ऐसी सिचुएशन आएगी कि आप ऐसा सोच पाओगे, जो फिश में अंदर देख रहा था और जो फिश में वाटर के थ्रू ऊपर से देख रहा हूं, the distance between both of the observation is something different. And why is it happen? It is due to that observation angle that you have. So over here, there are one principle is there, like whatever the light incident you are giving from more dense medium to less dense medium, and if those angle you are increasing so much, so it will be get back entire signal from that particular boundary, and that is considered as a total reflection. Okay, and that angle is considered as a critical angle. So जो भी मैक्सिमम एंगल है जहां पे आपका सिग्नल वो बाउंड्री पे ही चला जाए, and then after it is start reflecting, that angle is considered as a critical angle. Depend on that, the optical fiber is working on the same principle. So you need to launch a signal from dense medium to less dense medium, and over here what you are making, you are sending a light from one of the optical source, and that signal is going to be bounce back on the same particular guided area, and this principle is known as a total internal reflection. Okay, so आप लाइट लॉन्च कर रहे हो फाइबर में इस तरह से कि वो अंदर ही अंदर वो ट्रैवल करे and not escaping from the cladding. That phenomena is considered as an optical fiber total internal reflection phenomenon. So under that optical fiber characteristic, there are several type of the cables are there, that we can say single mode and multi-mode type of the propagation mode are there. Now multi-mode, we can say there are a thick cable, single mode which is a thin cable. Okay, so in thick cable there are two type of the I can say classification is the step index and graded index. Now what is a step index and graded index? This is the diagram of that. So over here, that the step index and graded index which is related to the refractive index of this particular communication. Now what is a refractive index? Refractive index is nothing but ratio of speed of light in a free space versus speed of light in any medium. You can say आप लाइट लॉन्च कर रहे हो एयर में से, और वो जब भी, जैसे हमने रिफ्रैक्टिव इंडेक्स का एक वेलोसिटी का और लैम्बडा का हमने इक्वेशन देखा था, लाइक इफ योर, जस्ट अ सेकेंड. Yes, sorry for interrupt. So as we have seen, like whenever we launching the any signal from one medium to another medium, that signal is going to slower down. वो signal का speed कम होता है. And whenever we take a ratio of that speed of light in we can say speed of light in a free space versus the speed of light in a medium. If you take a ratio, it will automatically give us the refractive index, n equal to c by v. Okay, so what is the refractive index? Refractive index is a ratio of n equal to c by v, speed of light in free space, speed of light in any medium. So आप किस तरह का refract, like now we can say for different material that refractive indexes differ. For the glass, for the, I can say, for the air, for any liquid, for any other material, the refractive index is going to be different. So if you take a refractive index constant for this throughout this I can say pink region, refractive index constant है ये पूरे region में, so that's considered as a multi-mode step index fiber. Now, what is the meaning of multi-mode step index fiber? Like whatever the core, there are two region is there, core and cladding. So under that core and cladding, your core is made up of only one type of the refractive index. So it's considered as a step refractive index. Okay. What do you mean by multi-mode? Multi-mode, it means their core diameter is thicker. While in सिंगल मोड योर कोर डायमीटर इज लोअर. अब देख सकते हो यहाँ पे बीच का जो केबल है उसका साइज बड़ा है, यहाँ पे छोटा है. So whenever there are a thin size of the center are there, it's considered as a single mode. While there are a thick size, it is a step. और वो thick size में भी refractive index of this entire thick size is constant, then it's considered as a multi-mode step index. But if the refractive index of that thick region, it is not constant, it is vary with respect to the distance. आप यहाँ पे देख सकते हो कि यहाँ पे सेंटर में उसका रिफ्रेक्टिव इंडेक्स सबसे ज्यादा होगा, और जैसे 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 वो आगे आगे क्लेडिंग तक जाएगा उसका रिफ्रेक्टिव इंडेक्स कम होता जाएगा. So we can say in the center, the refractive index is a maximum, and when you reach to the end of the fiber, that refractive index gradually getting decreased. So if such type of the cable you are creating, such type of the core you are creating, it is considered as a graded index. Okay, so there are three type of the fiber is there: step index, graded index, and single mode fiber. Okay, and these both are the multi-mode fiber. So what happened, like whenever you are launching such type of the source, that signal is going to spread it out, like whatever the pulse you have sent it, whenever it is reached, it will look like this one. It is getting spreaded in a multi-mode. So in multi-mode, signal is always going to be spreaded and interfere with each other. Pulse spreading are there, known as a dispersion also. While we can see in the single mode, it is not the case. Whatever the pulse you are sending, it is just change their shape, but it is not spreading. It is stuck to that particular time duration only. So these are the two effect is going to be generated in that step index, graded index, and single mode. What are the different type of the fibers are there? As I have told you, their cladding is going to constant. Whatever the outer region of the fiber is going to constant up to the 125 micrometer, while the core is going to vary. You can see in single mode, what is the size of core? Just the 7 micrometer. But while in a rest of the cases, while in the multi-mode fiber, that core is very high, 7 times higher than the single mode. It's a 50, 60 to 100 micrometer. So in multi-mode, the core diameter is higher, while we can say in single mode, core diameter is smaller, while that cladding is a constant in everywhere. These are the look for the fiber. There are cladding and core, such type of the structure is there. It is just protected with the plastic buffer. There are some strengthening material are there, outer jacket are there. So there are several layers or several coatings are there on that particular fiber to give them a flexibility, because it is a it is a, I can say, glass cable. It is a glass cable, and it is going to be a very tactile, or we can say it is very kind of the it's breakable. Okay, so to protect, to give that flexibility, it to prevent it from the breakdown, it is putting a several type of the layer to prevent their internal glass structure as same as, and it's not going to having crack in between them. So for that, there are different type of the strengthening, plastic buffer, outer jacket, TL are going to protect. These are the connectors are there. Okay, these are the optical connector, which is a subscriber channels, straight tip connector type of the cable we have. There are some MT RJ connector, but it is a two cable are simultaneously. Why there is a two cable are simultaneously? Because one is for transmitter, one is for receiver. So such type of the two in a pair of two cable are there, one for RX, one for TX. So there are a dual pin cable are available for those MTRJ, mechanical transfer register jack. Okay, okay, like that, fiber optic cable connectors are there. So whenever you see such type of the dual cables, these all are carrying optical fiber, and it's very thin cable. It's not that much of thick as a coaxial. जो कोएक्सियल केबल जो थिक होता है ऐसे थिक केबल नहीं होता, it is a thin. So whenever you see any switching center, whenever you visit any switching center, if you just pass by the second floor of our Marwadi University, and whenever you see the server room, in server room you can see there are several blue color cables are connected, and that switch is continuously tickling. So this all are, we can say, the fiber optic cables are. This is the profile. What is the profile of this particular fiber optic cable we have? So fiber optic cable, that a particular, okay. So in a fiber optic cable, what are the strength, or we can say what are the profile is there? So now you can say there are a loss. I can say it is very low. Whenever you see the attenuation loss in this another, this is attenuation. It is in dB per kilometer, which is a starting from 5 dB, and it is goes up to the 35 dB per kilometer. But when you see the loss of the optical fiber, it is a very low. You can say it is go maximum up to 10 dB. Minimum you are having a loss up to 0.25 dB per kilometer. So these are the loss profile we have. Like for some of the range of I can say 1600 and 1600 nanometer range, it means the frequency is a 200 terahertz. It's not a kilohertz, it's not a gigahertz, it's not a megahertz. It's a terahertz, 10 raised to 12 hertz of the frequency. So with that speed of light, or that speed of I can say a transmission you can achieve if you're using a fiber optic cable. And with this high speed also, it is having a very low loss, 0.25 dB per kilometer. So you, if you have spread the cable up to several kilometers, you can get the successful fruitful transmission from both of the sides. So that is the advantage of optical fiber performance, and that's why it is a more famous for the high speed communication, for a longer distance communication in all the sea. जो आप अभी यहाँ पे इंडिया टू अफ्रीका, इंडिया टू यूएस, इंडिया टू यूके, in a Pacific Ocean, in a Indian Ocean, there are a bunch of optical fiber cables already there since 1990 and 2000. Since that 1990, already the fiber optic cable are already there in underground the sea. Okay, and there are some that security force are there who are maintaining those fiber cable and all the stuff. So it's already there in a deep sea, which will make your faster communication from here to US, here to UK in fraction of second. You can send the data. It is due to those fiber optic connection available underground the sea. Is there any doubt, any question in this particular stuff? Any doubt, any question? You can open your mic and tell me. Chaliye, no question. Next, we will start with the unguided media. So what is the unguided media is there? Unguided media transport electronic wave without using a physical conductor. So we can say we don't require the cable to do this wireless communication. This type of communication is referred as a wireless communication. So there are radio wave is there, microwave is there. In waves, it means there are a frequency which can send through the air. Okay, that's the radio waves, microwave, and infrared wave is there. This is the particular range of the electromagnetic spectrum. So from 303 kilohertz to 300 gigahertz is known as a radio wave and microwave. Okay, up to the 300 gigahertz, it is a radio wave and microwave. After 300 gigahertz to 400 terahertz, it is known as an infrared wave. Okay, so from 300 to 400 terahertz, it's an infrared wave. While we can say from 400 terahertz to 900 terahertz, it is a light wave. So whatever the light wave that we are seeing, okay, whatever the red, green, blue, whatever the lights are there, which is come under 400 to 900 terahertz of the range. Okay, and that whatever the fiber optic cable with the red, green, blue, infrared laser that can work with respect to like 100 terahertz up to the 900 terahertz. So these are the spectrum we have: radio and microwave, infrared and light wave spectrum. So first of all, there are propagation methods that we need to discuss. So how the air, we can say wireless communication is going to take place, what are the conditions here? So we need to take care a condition of air with respect to what are the different layers are available in our earth. So if you have seen in any if you know such type of the earth geometry and earth geography, if you know that there are several layers are there in our air. It's ionosphere, stratosphere, mesosphere, troposphere, iono, strato, meso, tropo. If you know such type of the name, if you have gone or if you have here in any science related search or at anywhere in your 12 studies or 10 study, so these are the four layer are there. Okay, ino, stato, meso. Okay, so out of that, ionosphere is there, which is actually responsible for doing a long distance communication. How it is used as a mirror for the wireless communication. So there are three type of the communication is there: ground propagation, sky propagation, and line of sight propagation. So ground propagation will be like whatever the signal is going to send it from one particular tower, like it is going to be transmitted through the ground. Okay, it's considered as a ground as a zero, and according to that, that electromagnetic wave is going to be send it with respect to. So whatever the TV channel transmission are there, radio channel transmission are there, this all are considered as a ground wave propagation up to the, you can say, 2 megahertz. Okay, many time we can say I can say many times we can say whenever we are having a broadcasting in small area, that's considered as a ground propagation out there. Well, ionosphere, which is known when ionosphere will take place for reflecting those waves, is shown over here. It is considered as a sky propagation between 2 to 30 megahertz. Now, what is a sky propagation? Like whatever the signal you are sending, according to the ionosphere, it is reached to the ionosphere, and ionosphere work as a mirror for those signals. It is in some of the megahertz signals, so that's why it is getting back from those ionosphere, and you will receive it another station. So whatever the walkie-talkie, or I can say some of the amateur radio are there, this all are working with the ionosphere. So we can say those signal are getting bounce back from the ionosphere, and you can send those signal from one walkie-talkie to another walkie-talkie. Another type of the communication, which is a line of sight propagation based communication, and it is on the above 30 megahertz. So at that time we required a line of sight tower is there. So whatever the mobile communication you are using, okay, so in mobile communication you need to put a tower in such a manner that they both are in a line of sight. Okay, if they are not in both line of sight, communication not established. So those mobile tower that we are seeing around us, which is working on the principle of line of sight propagation. These are the band are there, and there are applications, and it is very important question for us. What are the band are there? There are a VLF, LF, MF, HF, VHF, UHF, SHF, EHF. There are a very low frequency to extremely high frequency, starting from 3 to 30 kilohertz and goes up to 30 to 300 gigahertz. And it is using a different type of the communication, initially up to the 300 kilohertz for radio beacons, navigator, locator, long range radio navigation. It is use a ground propagation, while the AM radio, I can say that citizen band, aircraft communication, it is working on sky communication. Okay, while we can say VHF, FM radio, UHF, cellular phone, satellite, radar, and all, they are all working on the line of sight, or we can say on the sky communication. So these are the applications are there with respect to the different type of propagation, their frequency range, and the name of those particular band. So whenever we can say satellite communication, it is goes from 300 megahertz to 300 gigahertz, and we require the line of sight antenna from here to Earth station, or from Earth station to we can say from Earth station to satellite, and satellite to Earth station, line of sight communication. So there are three basic classification: radio, micro, and infrared in our wireless transmission. For doing that communication, we required the omnidirectional antenna. Omnidirectional antenna, it means the antenna which will transmit the signal in all the side. Okay, from one antenna it will transmit the signal on 360 degrees. So we require the antenna which will generate their electromagnetic signal in all the 360 degrees. So whatever the surrounding area are there, all can receive the signal from that omnidirectional antenna. So whenever we have to do such type of the broadcasting like television transmission, radio transmission, we require the omnidirectional antenna. But for the specific communication with the mobile or from tower to tower, or we can say from satellite towards station, we require the directional antenna. Okay, unidirectional antenna, which is focused from one particular angle only. It is not in 360, but with respect to some specific angle only, like 0 to 20 degree, I can say. So it will emit their electromagnetic wave in specific direction only. So these are the type of the antenna which actually we require to do such communication. So radio wave are used for multicast communication such as a radio, television, and paging system, as I have told you, with this unidirectional antenna. Well, we can say another antenna, unidirectional antenna, also we have with the dish antenna or horn antenna. So this type of the antenna, it's not omnidirectional, unidirectional. It means it is in only one direction it will focus. So whatever the I can say that dish TV or whatever that set-top box you have at your home. So if you see which type of the antenna is associated with that set-top box, it is such type of the dish antenna is there. So this antenna is already there at all our homes, okay, on the top of our roof. So this antenna is focused on unidirectional only. So whatever the satellite is there, and that satellite is also considered as a geostationary satellite, which is continuously rotating as a synchronous pattern as per your Earth. जैसे जैसे अर्थ रोटेट हो रहा है, जितनी स्पीड से जितने टाइम में, उतने टाइम में वो सैटेलाइट भी अपना चक्कर कर रहा है. So we can say there is a lock or synchronized antenna, a synchronized satellite is there with respect to uh, your Earth. So such type of the antenna is used for the television broadcasting, and it is having a very unidirectional transmission is there. So with this antenna or such horn antenna, there are a unidirectional pattern we can observe. So microwave are used for the unicast communications such as the cellular telephone, satellite network, and the wireless LAN. Okay, so for the cellular, for the satellite, this is a unidirectional antenna or unicast antenna we require. So infrared signal, which is used for the short range communication in closed area, line of sight communication. Can anybody tell me what is the device? Which are the device you have observed in your life which will do the infrared communication? कोई मुझे बता सकता है कि इंफ्रारेड कम्युनिकेशन कहाँ पे यूज होता है? Where you have observed this stuff? You can type your answer in chat box. Remote control. True, Rohit. In a remote control, you are having a IR LED and IR transmitter and receiver is there. So that's the very small distance communication we have. IR LED is going to be used. Yeah, I have also shown you one of the video of solar panel. Harald has Li-Fi technology. So it not limited from only just with the shorter distance. With the technology which is right now available, name as a Li-Fi or free space optics, which actually use a infrared laser, or we use a visible light laser to transmit the data from one place to another place, or absorbing through the solar and convert it to data. So now the technology is changed, and we are having a such type of the IR in a fire detector, as well as we are having a stuff in a Li-Fi, or like in some of the remote control, or we can say in some of the cases of like I can say some of the in mobile also there are IR LEDs there in a projector. So we are having a such type of the use are there, but it's not limited to the nowadays. It's not limited for the small area. By using that free space optics and Wi-Fi, we can transmit through a longer area also, or at the longer distance also. True answer. So that's it about the all the communication, that type of the cables, I can say the type of the antenna, type of the communication, guided media, unguided media, coaxial cable, twisted pair cable, fiber optic cable. and we can say type of the propagation. Anybody having any doubt in this one? Please tell me if you have any doubt, any question. Any doubt, any question if you have. So what everybody do, there are a 10 minute of time. We have to, today we are going to do one exercise. What you have learned from this particular lecture, what you have learned from this lecture, you need to write a 10 line of the summary in the chat box, and you need to type it in the chat box here. Yes, Rutik, tell me. Hello. Yes, Rutik, you speak something. Any question, Rutik? Rutik Gajera, number 82. ठीक है, चलिए सब लोग, आपके पास 10 मिनट का टाइम है. यू हैव अ 10 मिनट ऑफ टाइम. स्टार्ट टाइपिंग अ समरी इन अ 10 लाइन. 10 लाइन में आज आपने क्या सीखा, समरी लिखिए और चैट बॉक्स में पेस्ट करिए. You are having a 10 minute of time to do that. Everyone start with this. So then after, at the end of the 10 line summary, you can write your enrollment number and name, and then you can go. But everybody, without that unguided media, entire unguided media, or what do you mean by that unguided media, Dux? Okay, meaning good. Unguided media, meaning of that, Dux, that you are not having any connector between them. Like you consider like that you are having a mobile phone. So mobile phone is a standalone remote device is there, and there are a mobile tower is there. So we are not having any cable connected between them. So that's considered as a or we can say remote communication, where the specific arrangement of the cabling are not required. We don't require any type of the permanent infrastructure, permanent cabling. We just need to have a one tower. From that, there are a electromagnetic wave are going to radiate it, and that radiated wave are going to capture by some of the device, and the communication take place. Like your, I can say your television broadcasting. So whenever the signal is launching from the satellite, so that satellite will launch the signal to entire India. So whatever the DTH service provider will tune that channel, they will receive those TV channel. अगर आप टीवी चालू करोगे, अगर आपके पास टाटा स्काई है, तो आप वो सैटेलाइट में से आप चैनल देख सकते हो. There are no permanent connection is between them. It is transmitting through the air. So whenever we are not fixing any particular cabling arrangement between them, it's considered as an unguided medium. Okay, so there are no specific cabling are there. That's the simple meaning of unguided media, and it can be changed anytime. Like you change your dish antenna from one home to another home. You just need to take care of those line of sight communication. That's it. Or you can say whenever you roam into the city, if you tune your radio, it will automatically give you the RJ and all the radio station you can directly listen. So it is जनरेटिंग फ्रॉम द ओमनी डायरेक्शनल एंटेना, जो यहाँ पे राजकोट में आजी डैम के पास एक एंटेना है. ओके, from that antenna there are omnidirectional transmission are there. Janice, I have told you about a 10 line summary, not just a one line summary. Okay, everybody. So there are a one master antenna is there from about this रेडियो ट्रांसमिशन, जो हमारे यहाँ पे आजी डैम के पास है. वहां से पूरे सिटी के लिए वो ब्रॉडकास्ट कर देते हैं. अभी जो अपना रेडियो ट्यून करेगा वो सुनेगा. सो दैट्स द सिंपल मीनिंग ऑफ द स्टफ, वेयर वी डोंट नीड टू फिक्सिंग एनी पर्टिकुलर. And guided media is opposite to, yes, guided media it means cables. Unguided media it means no cables. Simple, we can say like that. That's okay. So start writing summary, detailed summary, then your enrollment number, then you are allowed to. writing your summary, you can just write your enrollment number and then you can go. Yeah, so this all students are remaining in terms of writing summary. Do it quickly, guys. I need to end this lecture because next lecture is already starting. Quickly write your enrollment number, everyone. I need to end this lecture. Meet Man, Riddhi, Priyans, Anand Om, Das, Deep, Prati, Bhavik, Vaibhav,